the first defect that we are going to see in the plastic is called black specks. So black specks are basically like that black color dots that you can see in the picture, right? So the cause of these black specks are basically contamination in material, and another cause is heater band malfunction and contamination from the previous run. The previous metal would have been accumulated there and degraded polymers. So basically, you can the solution for this is that you can replace with a new material, and you can check for overrun or overheating, and you can clean the screw and barrel and hang up areas in screw and check valve areas. And for degraded polymer, you can lower the melt temperature, you can lower the back pressure, and you can lower the screw RPM also. So the next effect we're going to see is called bubbles, or you can call it blisters also. It's similar like as you can see in small bubbles will be there in the plastics and all. So this will be like solidified, and air will be mostly trapped inside this plastic material. So the main reason for this issue is we must have normally moisture in the material, or air will be trapped in the the mold lines, and due to the degraded polymers also. You can the solution for these issues is you can check the moisture level of material, and you can dry if it needed, and you can check the vents, and you can clean it, and you can reduce the clamp pressure to minimum amount, and the back pressure also. And for degraded polymer, similarly, you can lower the melt temperature, and you can lower the back pressure also, and you can normally basically that lower the screw RPM also. So another defect we're going to see is called brittleness. So brittleness is basically when you puncture a glass, you can see a little type of brittle, like there'll be many cracks will be there in the surface. So that's like the similar will be showcased in the plastic. So the cause for this is mostly there will be moisture in the material, and excessive melt temperature, and sometimes the melt temperature will also be low, and contamination can also be a cause. And sometimes there will be excess amount of regrinding. So regrinding is basically the processed part after it's been crushed and again used as a raw metal. So if you used in excess quantity, and also improper gate and size, and the location of the gate can also vary. The solution for this is you can check the moisture level, and you can increase the melt temperature, and you can inspect the resin for contamination, and you can purge the machine thoroughly, and for regrinding you can reduce the regrind, and for the gate condition you can increase the gate size to obtain the optimum filling. So the next effect we're going to see is called the burns in the gate area. So gate area is basically the end point of the part which comes out of the mold. So there'll be burn marks, like as you can see in this picture, like be some burnt area will be there. So the cause of this possible cause will be like there'll be burrs on the sharp corners at the gate point, and the gate size will also be small, and there'll be color concentrate in the shear sensitive area. So this remedy for this causes, you can polish the gate area to eliminate the rough areas and sharp edges, and you can also decrease the gate line length, and the gate size should be normally it will be around 50 to 80% of the nominal wall thickness of the part. And you can check the mold condition also in some of the cases, because most of these things won't be like visibly on the outer appearance part side. So it's better you can check all these things, and to avoid these kind of defects in the future. So the next defect we're going to see is the burns at the end fill. So end fill is basically the area, the end point of the part. The filling is done in the edges. So that is called the end filled. So these burns are the possible causes are due to the plug vents will be there, and over clamping, and inadequate vents, and melt temperature will be high, and the injection rate can also be faster. So for each cause, let me say, if you, for the plug vents you can normally clean the vents, and for over clamping you can reduce the clamp pressure to the minimum requirement, and for inadequate vents there will be the required vents should be larger, like 5 or 6 vents will be there, and you will be added only 3 or 2 vents, so you can add extra vents. And for melt temperature, when it's high you can reduce the melt temperature. And for the injection rate, if it's injection rate is very much fast, you can decrease the injection rate. So these types of defects are normally observed in the automotive and in the manufacturing sectors. Whether you are running an injection molding part, then these defects are much more common. So basically, most of the times we might have struggled to find what is the root cause. Instead of going through these causes, we might have gone through the material, and also I think this will be much more clearer to identify the real root cause. So the next effect we're going to see is called cracks. So cracks are basically how you can see in the picture, right? So there will be crack-like surface, crack-like visible in the surface of the part. So basically, the cause of these cracks in the plastics are, the first one is contamination, and another one is during the part removal. So improper part removal can also be a cause, and the packing excessive material. So excess material will be packed into the mold, and another one is non-uniform or too cold of the mold temperature. The mold temperature will not be a uniform cooling, and the another one is a chemical contamination. So the solution for these things are, for contamination you can use a different type of material, and you can eliminate regrinding also, and you remove colorant also in some cases. And for the part removal, you can redesign the knockout system for ejection, and you can revert the mold and provide adequate drafts and angles so that the part you can eliminate the excessive undercuts and all. And for packing excessive material, you can decrease the pack pressure, and you can decrease the short size. And for uniform cooling, you can increase the mold temperature and supply uniform cooling to cavity. And for chemical contamination, you can clean the mold properly. Another cause is called delamination. So delamination, the causes for this defect is melting temperature will be low, and the material contamination will be there, and injection rate is also will be low, and entrapment, sometimes air will be stuck inside the mold, and the mold temperature will also be low. So the remedy for each causes, for melt temperature when it is low, you can raise the melt temperature. And for the material contamination, you can check the material feed system for any contamination available, or you can try a different box of material or a packet of material. And for the color concentration, if there is an issue, you can try virgin, or try to change the color to another concentration if needed. And if the injection rate is low, you can increase the injection rate also. And if there is air entrapment and air is available inside the mold, you can increase the venting to increase the escaping of the air. And for when the mold temperature is low, you can basically increase the mold temperature to the required specification or the required SMP which has been provided. So these are the causes, and for the defects, and what is the solution needed for delamination. So these kind of defects are rarely faced compared to the other defects which are observed in plastic parts. So the next defect we're going to see is dimension inconsistency. So dimension inconsistency is basically the variation in the dimension. So what should be the standard, and it might have been varied, and out of the standard. So these things, the possible causes for these things are normally non-uniform feeding of the material, and insufficient packing of the part, and regrinding levels will be not consistent, and melt pressure will be, there will variation in the melt pressure, and an unbalanced runner system. So the remedy for these things are, for for normally non-uniform feeding of material, you can adjust the temperature to the optimal film filling, and you can increase the short size to maintain proper cushion, and you can replace the check valve, and so that in case the cushion cannot be maintained. Okay, so in case of insufficient packing of part, you can increase the ejection forward time and pressure to ensure the gate freezing of the part. And in the regrinding levels, you can review what kind of regrinds has been used, and you can also decrease the level of regrinding. And for melt pressure variation, you can increase the fill pressure to maintain the selected velocity for the mass for mold run. And for the unbalanced runner system, you can increase the holding pressure to maximum, and increase the ejection rate, and balance the running, and gate size to provide balanced filling. So the next defect we're going to see is called discoloration. So discoloration is basically a difference between the color of single surface, as you can see in the picture. So the cause of this discoloration is, the first one is material overheating, and another cause is material will be oxidized by drying at a high temperature, and another cause is contamination by the foreign material. So the remedy for these causes, you can see by for the metal overheating, you can decrease the melt temperature, and you can decrease the screw RPM, and you can decrease the back pressure and resilient time, and you can check the barrel and nozzle heater bands also, and the thermocol also you can verify. And for in case of material oxidized, you can set the drying temperature at the manufactured recommended settings. And the contamination, you can just review the metal handling procedures, how the metal has been handled, and you can purge the injection cylinder. So check any possible other material or any contaminants available. So these things can be checked in case of discoloration, but discoloration is mainly for the aesthetic parts. So this can be a major issue if the customer requires the part to be aesthetically correct and without any visual defects. Another effect we're going to see is the sink marks. So the reason for the sink mark is due to the improper part design and insufficient pack and hold time, and insufficient volume of the material, and due to sometimes the gate also freezes off before properly packing out the part. So the remedy, the solution for these causes is for the improper part design. You have to core out the wall thickness section, and in case of insufficient pack and hold times, you have to ensure the pack and hold time is sufficient for the gate freeze by performing a gate freeze analysis. And in case of insufficient volume of material, you can increase the short size to maintain a constant cushion, and you can inspect the non-return valve for wear and tear. And in case of the gate freezes off before properly ejecting out the part, you can increase the size of the gates and the runner, and you can also increase the size of the nozzle and the sprue. So the sink marks are normally, these things are more observed, like when you're preparing a part in the injection molding. So these things are like, the starter parts will be there. So these things are observed regularly. So the next effect we're going to see is called short fill or short shots. So short fill is basically the generic term used in the manufacturing and the injection molding. So everywhere you can find these defects. The short fill will be common in almost everywhere. So during the startup time, you can observe these kind of defects. So apart from the startup time, if it's these defects are occurred in the running time, then the following causes will be the reason for that. That the one is melt temperature will be low, and the mold temperature will also be low, and sometimes there will be insufficient metal volume will be there, and sometimes the air entrapment will be there. Due to this, you have observed these defects while in the running condition, then we can make. The next defect we're going to see is called a silver streak. So silver streaks are common as a short fill, which I've explained earlier. So the cause of the silver streaks is due to the excessive moisture will be there in the material, and the melt temperature will also be high, and there will be excessive shear heat. And another cause is the air entrapment will be there between the mold lines, and the fifth one is condensation or excessive lubricant will be used on the mold surface. For normally polishing, there will be the mold spray. So when you're applied too much of it, so you can counter these kind of defects. And there will be moisture condensing will be there in the feed section of the barrel. So normally, like similarly, what I've explained, that in the startup condition, these kind of defects will also be found. But in the running condition, if these issues occur, then you have to check the possible cause and the remedy. So the remedy for these, like for excessive moisture, you can dry the material according to the manufacturer's recommendation. And if the melt temperature is high, you can decrease the barrel temperature and the nozzle temperature. And if there is an excessive shear heat, then you can reduce the screw RPM. and you can decrease the injection rate and increase the gate and the runner size and check the nozzle for obstruction. And if there is an air entrapment is there, you can reduce the screw decompression and improve the mold venting. And in case of excess lubricant on mold surface, you can increase the mold temperature and clean the mold surface also, and you can minimize use of the mold release. And for the moisture issue, you can increase the rear zone temperature. Next effect we're going to see is surface imperfections. So surface imperfections is basically glass will be there on the surface, like there will be improper texture on the surface. So the possible causes for this defect is melt temperature will be low, and the mold temperature will also be low, and the insufficient packing of the part can also contribute the cause, and insufficient material will be there in the mold, and injection rate will also be slow, and sometimes you can also find water on the mold surface, and moisture will be there also in material, and inadequate venting can also be a cause. So the remedy, the actions which can be taken in case of material temperature is low, you can increase the melt temperature, and in case of mold temperature also you can increase the same, and if the packing is insufficient, you can increase the pack pressure, and in case of insufficient material, you can increase the short size and maintain constant cushion for this issue, and you can also decrease the injection transfer position. And if the injection rate is slow, you can increase the first stage pressure and boost up time, and also increase the injection speed. And if you have found water on the mold surface, you can increase the mold temperature, and look for water leaks and repair if needed. So you can also clean the mold surface and use mold release, mold release spray also can be used. And you can also review the how the metal has been handled, and you can review the metal handling procedures, and you can dry material prior to the molding. And in case of venting is required, you can also increase the number of vents, and you can check the mold regularly for these kind of issues. So the next event we're going to see is called a warpage. So warpage is basically the change of the profile of the part itself. As you can see in the picture, there is a change in the how the part should be and how the part has been bent. And these parts cannot be used for fitment or any other purpose instead of scrapping the part. So these the causes for these warpages. Sometimes the part can get ejected while it's too hot, and there will be a non-uniform shrinkage within the mold, and sometimes the pressure, the mold temperature will be much lower, and there will be non-uniform wall thickness will be there, and sometimes there will be insufficient packing and holding pressure will be there, and there will be differential mold cooling in all the surfaces. So the remedy, the how these things can be solved is, we can decrease the melt temperature and you can decrease the mold temperature, and you can also increase the cooling time in case of the part is ejected while being too hot, and you can cool the part in the warm water after ejection. And in case of checking, you can use the secondary fixture to hold the part dimensions also. And in case of shrinkage difference, you can increase the injection rate and increase the back pressure, and balance the runner and gate size. And if the melt temperature is too low, you can increase the melt temperature also to provide a better pack out of the part. Okay, and in case of shrinkage difference due to uniform wall thickness, you can increase the cooling time, and you can redesign the part with uniform wall thickness. And in case of insufficient packing and hold times, you can add the pack and hold time or pressure. And in case the ejection system is poorly designed, can be caused someday, you can redesign the ejection system, and you can balance the mold temperature. Another effect we're going to see is called a well line. So well lines are basically how we can see in the picture, right? There will be small streaks like formation. There will be small line like projection. So these things are called well line. So well line, the cause of this well line is sometimes the material, the mold temperature and the melt temperature will be too low, and sometimes there will be insufficient pressure at the well line, and there will be air trapped inside the mold, and the ejection rate will be slow, and sometimes the flow distance from gate to well line area will be excessive. So this, the remedy, the actions that can be taken for these causes is, you can increase the melt and the mold temperature if it's too low, and you can in case of insufficient pressure at the well line, you can increase the first stage injection pressure, and you can increase the boost time, and you can increase the pack pressure and pack time, and you can also increase the injection rate and speed. And in case of air trapped in the mold, you can increase the vent at the weld area and decrease the injection speed to allow air removal, and you can also decrease the clamp pressure to minimize minimum pressure. And in case of injection rate is slow, you can increase the injection speed, and you can increase the boost time, And if the flow distance from the gate to weld area line is very much excessive, you can relocate the gate or use multiple gating in that case. And you can also utilize overflow tab and the mold to increase the strength in weld line area. So these are like whatever defects I have been explained. Like these things are like commonly these defects are much more visible, much more frequently occurrence. Like you face these kind of defects regularly, so it's necessary to point out what is the exact cause for these type of defects, because normally when in industry, when we are checking for a defect, we go through another unnecessary parts and unnecessary analysis. So I hope these things will be, whatever I explained might be a clear idea to you. So that's it guys, this is from me. Thank you for listening till now. So thank you for watching this video, and I hope you really found it really useful, and do subscribe for more such interesting contents.